Welcome back to The Science Pulse. Tonight, we're not racing through galaxies or diving into black holes. Tonight, we're slowing down, drifting into something deceptively small, yet infinitely mysterious. Moon dust. It clings to every footprint still etched into the lunar surface, untouched for more than half a century. It coats the silent plains where no wind will ever blow it away, and it carries secrets NASA still doesn't fully understand. I'd love to know where you're listening from and what time it is for you. Somewhere, across the world, another listener may be settling into bed at this very same moment, hearing these same words. We're all scattered like stars, but connected by this quiet rhythm of listening, learning, and drifting off together. So for now, take a breath. Let your shoulders sink just a little deeper into the pillow. Loosen the jaw, release the day. You don't need to remember everything. Just let the words float past like dust in a quiet shaft of light. Settle in, get comfortable. Let's begin our journey into the silver-gray mystery of the moon's forgotten powder. Picture the silence of the 20th of July. The moon hangs still in the blackness of space, suspended in an endless void without wind, without breath, without sound. For billions of years, it has turned the same face toward Earth, a sentinel keeping silent watch over the oceans, the forests, the slow rise and fall of civilizations. And then, after this long eternity of solitude, something changes. A small machine, fragile against the vastness, touches down on its surface. From the hatch, a man descends. His movements are cautious, deliberate, slowed by the weight of the suit, and the knowledge that one misstep could undo years of planning. A gloved hand steadies against a ladder. The visor reflects Earth, blue and glowing far behind. Below him, a plain of gray stretches endlessly, a desert of fine, powdery material untouched since time itself began. It looks familiar, like sand on a quiet shore or snow in moonlight. Yet, it is something stranger. His boot hovers, then presses down, and history changes forever. A footprint carved into dust that has lain undisturbed for aeons. A mark that will remain, preserved for millions of years, because there is no wind, no rain, no erosion here to erase it. But beneath that romantic image lies a truth far less poetic. The dust that cushioned his boot was not smooth, not soft, not harmless. It clung to the astronaut's suit like ash. It scratched their visors, scuffed their gloves, and when they carried it back into the lunar module, it released a smell acrid, metallic, like burnt gunpowder. Imagine standing inside that small cabin, only the hum of machinery and the hiss of oxygen in your ears. The dust floats, catching the pale cabin lights, drifting across helmets and consoles. You brush at it, but it clings. You breathe, and the smell reaches you sharp, reactive, alien. The moon has given you its touch, and its touch is stranger than anyone had imagined. The dust had a name: lunar regolith. At first glance, regolith seems simple, a blanket of crushed rock covering the moon. But like everything in space, it hides complexity. Unlike Earth's sand, worn smooth by rivers and oceans, lunar dust is jagged, raw, unfinished. Each grain is born from violence. With no atmosphere to protect it, the moon is struck constantly by meteoroids. Large impacts carve craters, hurling out shards of rock and glass. Smaller particles, micrometeorites no bigger than a grain of sand, bombard the surface endlessly, day and night. Each collision shatters rock, melts fragments, sprays them outward. Over billions of years, the surface has been ground into a powder, finer than flour, but sharper than glass. Under a microscope, these grains look like shards of obsidian, full of edges and hooks. Imagine walking barefoot across a desert, not of soft sand, but of ground glass. That is, the texture astronauts carried home on their boots. The grains are also electrically charged, bathed constantly in ultraviolet light, and bombarded by solar wind. Lunar dust builds up a static charge. This makes it cling to everything: fabric, metal, even skin. Once disturbed, the dust resists settling, drifting upward, floating longer than you'd expect in the moon's weak gravity. Astronauts described how it coated every surface, sneaking into hinges, clogging seals, scratching visors. And then there was the smell. When the astronauts removed their helmets inside the lunar module, they noticed it instantly. The dust that clung to their suits smelled, they said, like gunpowder. A strange description, because there is no oxygen on the moon, no fire, no combustion. The smell was a chemical illusion, created when the sharp grains reacted with moist air inside the cabin. For a few moments, the dust lived again, changing when it touched human breath. But the encounter was not harmless. The dust irritated their eyes and throats. Some astronauts coughed and sneezed. They worried, briefly, about whether this strange gray powder might be toxic. NASA later studied lunar dust samples brought home and found reasons to be cautious. The jagged particles could lodge deep in the lungs, where the body struggles to remove them. The fine shards might irritate tissue, triggering inflammation, perhaps even long-term damage if exposure continued. Dust on Earth is often smoothed by weather, rounded by water, coated by organic films. Moon dust is unweathered, sterile, raw. In a sense, it is dust in its most ancient form, the kind that covered Earth before oceans and atmosphere softened it. To breathe it deeply would be like inhaling the very beginning of geology itself. The astronauts were lucky; their exposure was brief, but even short encounters left impressions. Buzz Aldrin recalled that brushing the dust from his suit was nearly impossible. It clung to Velcro, to gloves, to equipment. When they tried to wipe it off, it scratched surfaces instead of releasing them. Lunar dust was not just a passive landscape, it was an active force, reaching into every corner of the mission. Imagine trying to live with it, day after day. Imagine a habitat where every time you return from a walk outside, this gray powder follows you in, grinding into machines, filling the air, scraping at lungs. For future explorers, lunar dust will be both a constant companion and a formidable adversary. And yet, in its stubbornness, there is also something remarkable. Each grain of dust carries within it a record of the moon's story. Trapped inside are tiny fragments of glass created by ancient impacts, particles altered by radiation from the sun, clues to the violent history of the solar system. To hold a pinch of lunar dust is to hold a library of cosmic events, explosions, collisions, transformations, all written in gray. No wonder astronauts couldn't stop staring at it. It was both nuisance and wonder, hazard and treasure. Dust has always carried symbolism for us. On Earth, we say dust to dust when we speak of endings, of returning to the soil. Dust is the residue of time, the remnant of what was once whole. It is the stuff we sweep away, the background of our lives. But on the moon, dust takes on a different role. It is not an end, but a record. Each grain is a page torn from the diary of the solar system. Some grains may be billions of years old, unchanged since the earliest days of planetary formation. Others were born in a sudden flash, the instant a micrometeorite slammed into rock at thousands of miles per hour. Together, they make a mosaic of time, spread across the moon like an endless archive. And when a human foot pressed into that archive, the story of Earth and Moon entwined. For the first time, dust that had never known life met a living being. It clung, as though unwilling to let go, as though insisting that this moment be remembered. The astronauts carried it back not only in their bags but in their lungs, their suits, their very skin. For days, they smelled like the moon. There is something strangely intimate in this. To step onto another world is not just to see it, but to let it touch you, to breathe it, to carry it home. The moon shared its oldest substance with us, and we discovered that even dust can be alive with meaning. And so the first touch of dust was not just a step for mankind, but a revelation. The moon was no sterile marble, no smooth surface waiting for our footprints. It was an abrasive, reactive, stubborn world that left its mark on those who touched it. But to truly understand this strange powder, we need to look further back, not to 1969, but to the deep past, when the moon itself was born, and when the first grains of this dust were forged. Let's drift back in time, to the ancient origins of lunar dust. Ancient origins. Where did all this dust come from? It seems so ordinary, gray powder clinging to boots, drifting in thin layers across craters and plains. And yet, every handful of lunar dust is older than every city, every river, every life form you've ever known. When we trace it back, we discover that lunar dust is not just the debris of rocks. It is the residue of an ancient violence, the remnant of collisions so vast that they reshaped the solar system itself. To understand the dust, we must step back billions of years to the very birth of the moon. Imagine the sky of a newborn Earth. It is not calm blue, but molten orange, glowing with oceans of lava. Volcanoes roar, and the surface shifts constantly, reshaped by impacts from leftover debris that still swarms the young solar system. And then the event, a collision beyond comprehension. A protoplanet, about the size of Mars, strikes the Earth. The force is so great that part of Earth itself is hurled into space, a spray of molten rock and vapor stretching into orbit. From this chaos, the moon is born. Slowly, fragments pulled together by gravity, cooling, hardening into the familiar sphere we see today. For a while, its surface is an ocean of magma, glowing red beneath a black sky. As it cools, crust forms, mountains rise, and impacts continue, raining down relentlessly. Now picture it, a silent gray world, every square inch scarred by bombardment. No air to soften the blows, no water to heal the scars. Every strike breaks rock into shards, melts stone into glass, and scatters fragments into a growing blanket of dust. Over billions of years, this layer deepens, becoming the moon's skin. When you see the moon tonight, you're looking not at a smooth sphere, but at a world wrapped in billions of years of shattered history. The moon's dust is the product of three main processes: impact bombardment, solar radiation, micrometeorite weathering. Let's take them slowly, one by one. 1. Impact bombardment. Without an atmosphere, the moon cannot shield itself. Every meteorite that passes through Earth's skies, as a harmless shooting star, strikes the moon with full force. Large impacts carve out basins like Mare Imbrium and Tycho, hurling ejecta across the surface. Smaller impacts, happening constantly, break down rocks into finer fragments. Over billions of years, this unending bombardment creates a layer of regolith that can be several meters deep. Think of it as an ongoing cosmic quarry. Every strike shatters more rock, adding endlessly to the dust. Unlike Earth, where rain and rivers wash debris away, on the moon the fragments accumulate, century after century, building a timeless archive. 2. Solar radiation. Every day, without an atmosphere to filter it, the moon is bathed in solar wind, a stream of charged particles rushing outward from the sunday. These particles interact with the dust, altering its chemistry. Atoms of hydrogen and helium embed themselves in grains, leaving behind traces of the sun's influence. Some oxygen is knocked free from minerals, combining to form tiny molecules of water bound within the regolith. In other words, moon dust is not static. It is constantly rewritten by solar wind, charged and altered by invisible currents of energy flowing through space. 3. Micrometeorite weathering. While large impacts shape craters, the real sculptors of lunar dust are the countless micrometeorites, grains of cosmic sand, traveling at tens of thousands of miles per hour. Each one is a bullet, small but devastating. When they strike, they melt and vaporize tiny spots on the surface, creating glassy beads called agglutinates. Under a microscope, these look like little black pearls mixed into the dust. Over time, this process darkens the lunar soil, giving the moon its characteristic gray tone. A fresh crater, with unweathered rock, often looks brighter, while older surfaces grow darker as they are coated in glassy remnants of countless micrometeorite strikes. By studying lunar dust, scientists can reconstruct the moon's past. Each layer of regolith is like a page in a book, holding clues about ancient impacts, solar wind cycles, even galactic events. Some grains contain traces of cosmic rays that passed through the solar system millions of years ago, embedding their history inside the dust. In fact, lunar dust may preserve a more complete record of the sun's history than Earth does. Our planet's atmosphere and tectonic shifts erase old traces, but the moon, with no air and no geological activity, keeps its archives intact. Dust on the moon today may carry signals from a sun that shone differently billions of years ago. And here is a striking thought. The very grains that clung to Neil Armstrong's boots may have witnessed the birth of life on Earth, the rise and fall of the dinosaurs, and every age in between, lying there, unchanged, waiting for us to arrive. There is a quiet poetry in this. Dust is usually what we sweep away, what we ignore, what gathers in forgotten corners. But on the moon, dust is not forgettable. It is memory itself. Each grain is a survivor of unimaginable violence, a record of collisions so fierce they could melt mountains, yet frozen now in silence. They are the whispers of the solar system's youth, scattered across a lifeless plain. Think about this. Every breath you take contains oxygen once forged in stars, carbon once drifting in space. But moon dust carries no breath, no life. It is raw, untouched, eternal. To hold it would be to touch the oldest scars of creation, fragments of a cosmic wound that has never healed. There is something comforting in that constancy. Earth changes, seas rise, forests grow, civilizations build and fall. But the moon's dust remains, watching quietly as ages pass. In its stillness, it reminds us that we too are fragments of an ancient story, carried forward through time. And so, the moon's dust is not just an accident of geology. It is the product of fire and impact, of radiation and time, a record of everything the solar system has endured. But dust is not only history, it has also experienced something astronauts discovered when they lived among it. For the moment they stepped inside their cabin, the moon followed them home. It clung to their suits, filled their lungs, scratched their throats. Let's step inside the lunar module and listen to the astronauts describe their strange encounters with moon dust, astronaut encounters. What was the very first complaint every astronaut had after stepping onto the moon? Not the weight of their suits, not the silence of space, not even the dizzying thought of standing on another world. It was the dust, the gray, clinging powder that followed them everywhere, the substance that seemed to whisper, "You can leave your footprints here, but I will leave my mark on you as well." For those who walked the lunar surface, moon dust was not just scenery. It was a constant companion, invasive and unforgettable. Picture the interior of the Apollo lunar module. It is no larger than a small camper van. Two astronauts, exhausted after hours outside, clamber back through the narrow hatch. Their suits are bulky, stiff, and heavy with life support systems. As they squeeze inside, they bring with them the moon itself. The dust comes first on their boots, then it rubs off on the floor, smears across gloves, brushes against instruments. Soon the cabin air is filled with a faint smell, something sharp, metallic, unexpected. Astronauts describe it again and again. It smelled like burnt gunpowder, not the sulfur of fireworks, but the acrid tang of something scorched, reactive, unsettled. And though they were millions of miles from home, it was the one smell that seemed familiar, the ghost of a battlefield carried into a fragile bubble of life. Inside the small cabin, the dust does not stay put. In the moon's weak gravity, stirred by every motion, it drifts easily. When helmets come off, particles reach eyes, noses, throats. They make the astronauts cough. They scratch at skin. The dust is inescapable. Imagine lying down after such a day, your face still tasting faintly of gunpowder, your suit streaked with gray, your lungs irritated by an alien substance. Sleep would not come easily. The Apollo astronauts reported several consistent experiences with lunar dust. 1. Clinginess. The dust adhered stubbornly to everything. Velcro, zippers, fabric, nothing escaped. Its jagged grains locked into fibers, refusing to be brushed away. When they tried to clean it off, it abraded surfaces instead of releasing them. Charles, Duke of Apollo 16, said it was like charcoal dust, but it sticks like nothing else. 2. Abrasiveness. Dust worked its way into joints and seals, scratching them. It wore at visor coatings, dulled suit materials, and threatened to damage delicate equipment. On Earth, sandpaper smooths wood by abrasion, On the moon, dust turned suits and tools into surfaces worn raw. Number 3. Smell and irritation. Every astronaut noticed the strange smell. Once dust mixed with moist cabin air, reactions occurred that released odors unlike anything experienced on Earth. Several astronauts reported sneezing, watery eyes, and throat irritation. Harrison Schmitt, Apollo 17's geologist, developed what he jokingly called lunar hay fever. 4. Inhalation risks. NASA later studied the dust under laboratory conditions. Some grains are so fine they rival cigarette smoke in size. On Earth, lungs can gradually clear dust particles, but the jagged edges of lunar dust may slice into tissue, causing inflammation or fibrosis. The risk of long-term exposure remains unknown, but serious. 5. Electrical behavior. Even inside the module, dust behaved strangely. Electrostatic charges caused it to float, to leap from surfaces, to cling in ways that defied simple cleaning. It acted almost alive, moving where it wasn't wanted. Voices from the moon. The astronauts' own words bring the story alive. Gene Cernan, Apollo 17. Dust got on everything, and I mean everything. We were black from the knees down with this thick, abrasive dust. Buzz Aldrin, Apollo 11. The smell in the cabin, it was like gunpowder, a burnt odor. It got in your throat and eyes. Harrison Schmitt. Dust is the #1 concern in returning to the moon. It penetrated every opening, every pore. It was a problem we never solved. These were not exaggerations. NASA spent decades afterward analyzing dust samples, trying to understand just how dangerous they might be. Beyond engineering concerns, dust had a psychological effect. Astronauts described feeling constantly dirty, coated, never fully clean. Imagine spending days in a confined cabin where every surface feels gritty, where every breath tastes faintly metallic. On Earth, you would simply shower. On the moon, there was no escape. The irritation was not only physical, but mental. Dust turned pristine equipment into grimy tools. It made the extraordinary look ordinary, smudged with gray. It dulled the gleam of visors, coated the American flag they planted, muted the sparkle of newly collected rocks. The moon was asserting itself, saying, "You can visit, but you cannot remain untouched." What would happen if humans stayed longer? The Apollo missions lasted only a few days at a time. Future explorers may spend months. Will dust slowly erode their suits, their machinery, even their lungs? Could long-term exposure lead to serious illness? Might habitats become clogged, filters overwhelmed, air unsafe to breathe? These questions remain urgent as NASA's Artemis program prepares for a return. Dust is not a solved problem. It is a challenge that engineers still wrestle with, designing new suits, new filters, new methods to keep lunar homes clean. And yet, despite its nuisance, astronauts spoke of dust with awe. They knew they were touching something ancient, elemental, foreign yet familiar. They carried home samples in sealed boxes, treasures that scientists still study decades later. There is an intimacy in this story. The moon did not simply allow visitors, it embraced them in its own abrasive way. Its dust clung like memory, lodged in fabric, in lungs, in thoughts. It followed them home. Think of it. When Neil Armstrong returned to Earth, his suit carried traces of the moon. That dust passed through Earth's atmosphere for the first time in history, sealed in boxes and jars. It sits now in laboratories, still gray, still sharp, still smelling faintly of gunpowder when opened. The moon is here among us, in specks no bigger than a breath. Dust has always been part of human life. We clean it from shelves, sweep it from floors, brush it from our skin. But lunar dust is different. It is not the residue of living things, not pollen or ash or skin. It is the residue of silence, of impact, of time itself. To encounter it is to realize that even the smallest fragments of another world can alter our own. The astronauts gave us stories of dust as nuisance, as hazard, as unwelcome guest, but their reports hinted at something stranger still. Dust did not always behave as expected. At times, it seemed to rise, to move, to glow faintly above the horizon as if alive. Let's drift into this next mystery, where dust itself seems to defy gravity. The tale of the levitating lunar dust. The dust that levitates. How can dust defy gravity on a world with no air? Astronauts saw it. Robotic probes before them hinted at it. A mysterious glow rising from the lunar horizon, faint, like mist on Earth at dawn. Yet there is no atmosphere on the moon. No wind, no haze. Nothing that should shimmer in the air. And still, the dust seemed to lift, to hover, to dance. A riddle in plain sight, as though the moon were breathing softly into space. Close your eyes and picture the moon at twilight. The sun has just set beyond the jagged horizon of a crater. Shadows stretch long and sharp, black against silver. In the distance, the sky remains ink dark, scattered with stars unblinking. And then a glow. Faint at first, a thin band of light appears just above the horizon. It is not sunlight, for the sun is gone. It is not earthshine, for it rises from the ground itself. Astronauts aboard Apollo command modules saw it with their own eyes. A strange luminescence, like a mist lifting from the surface. Surveyor probes that landed before Apollo captured something similar. Cameras pointed low to the horizon, recorded a subtle glow, dust, it seemed, suspended in the airless void, shimmering in the stark light. How could this be? Dust without wind, motion without breath, a mystery without explanation. The phenomenon is known as horizon glow, and its cause is thought to be electrostatic levitation. Here's how it works. 1. The charging of dust. The moon's surface is bombarded constantly by ultraviolet light from the sunday. With no atmosphere to absorb it, the radiation strikes directly, charging the dust grains with electricity. At the same time, the solar wind, a stream of charged particles, sweeps across the surface, adding further charge. On the sunlit side of the moon, dust becomes positively charged. In shadow, it may be negative, where the two regions meet along the terminator. The line between day and night electric fields form. These invisible fields tug at the smallest dust particles, lifting them off the ground. 2. Levitating grains. Once airborne, these grains don't fall quickly. The moon's weak gravity means they can drift, float, even hop in graceful arcs before settling again. The smallest particles, some no wider than smoke, may remain suspended for long minutes, forming a kind of ghostly veil above the surface. 3. The glow. When astronauts described the horizon glow, what they were likely seeing was sunlight scattering off these levitating particles. Just as dust motes in a sunbeam glow in a darkened room, lunar dust catches light and shines against the black of space. Scientists have proposed something called the fountain model. Imagine dust grains charged and lifted by electric fields, then arcing gracefully back down like tiny fountains of powder. At the scale of the moon, these fountains could rise hundreds of meters, even kilometers, before settling. This creates a kind of ever-moving ballet of particles, rising and falling, drifting and glowing. Not clouds, not mist, but an invisible tide of dust, always in motion even when the surface looks silent. Apollo 17 carried a small experiment, the Lunar Ejecta and Meteorites (LEM) detector. It was designed to measure dust. To the surprise of scientists, it recorded spikes at twilight and dawn on the moon, just when charging effects would be strongest. Dust, it seemed, was active, restless, refusing to remain still. At first, horizon glow might seem like a beautiful curiosity, but for future explorers, it has deep implications. Surface operations. Dust that levitates can infiltrate equipment, even when untouched. A habitat could find fine particles settling inside unexpectedly. Solar panels and instruments. Floating dust may coat delicate surfaces, blocking light or interfering with sensors. Astronomy. A veil of glowing dust could affect telescopes placed on the moon's surface, scattering light and obscuring faint objects. Science. By studying how dust moves, scientists learn not only about the moon, but about other airless worlds, asteroids, Mercury, even the moons of Mars. All may share this restless behavior. The moon teaches us that silence is not stillness. Even in a place without air, the smallest fragments can rise, float, and wander. For the astronauts, the sight was haunting. Imagine orbiting above the moon, staring at a world you thought was barren and motionless, only to see it shimmer faintly, with a glow no one had predicted. Gene Cernan described the lunar atmosphere, though of course there was none, as feeling alive, as though the surface exhaled faintly. Others spoke of watching the glow with unease, unable to explain what they were seeing. It was one of those moments where the moon seemed less like a dead rock and more like something with presence, agency, mystery. There is something dreamlike in the thought of dust that rises without wind. On Earth, dust floats only when stirred by air, by footsteps, by breath. But on the moon, dust moves to invisible forces: sunlight, electricity, the silent tide of particles streaming from the sunday. It is as though the moon has its own secret breath, not of air but of light, a slow inhale when the sun rises, a soft exhale at twilight, a rhythm too subtle for sound, but written in drifting motes of gray. And there is beauty in this idea, that even on the most barren of worlds, movement persists. Even in silence, there is dance. Even in stillness, there is change. The moon is not dead. It whispers through dust. So the moon's dust does not simply lie quiet beneath our boots. It rises, it glows, it drifts in unseen fountains across the horizon. A mystery turned discovery, a nuisance turned wonder. But beauty is not the only story. For the engineers and dreamers who imagine lunar colonies, dust is not just poetic, it is peril. Next, let us explore why this humble powder may be the single greatest obstacle to building a home on the moon. Dangers for future colonies. Why is dust the #1 engineering problem for a moon base? When you imagine building a home on the moon, perhaps you picture vast domes under the stars, solar panels stretching across the plains, astronauts walking between habitats with ease. But ask NASA engineers what keeps them awake at night, and the answer is not radiation, not food, not even oxygen. It is dust. The same gray powder that clung to Apollo boots is the greatest threat to tomorrow's colonies, abrasive, invasive, and nearly impossible to tame. Picture a lunar habitat in the not-so-distant future. A shining dome rests on the surface, its walls layered to shield against radiation. Solar arrays stretch outward, drinking in sunlight. Rovers crawl across the plains, carrying supplies from crater to crater. At first, all seems well. The air inside is clean. The power flows steadily. The astronauts step outside in suits that gleam under the unfiltered sunday. But then, dust. It rides in on boots. It clings to gloves. It coats the seals of airlocks, slipping inside no matter how carefully brushed away. It creeps into hinges, gears, and filters. Each day the layer grows thicker, dulling surfaces, scratching screens, covering panels in gray film. The machines begin to labor, the airlock groans, the power dips, and soon the astronauts realize their greatest enemy is not the emptiness of space, but the countless tiny grains beneath their feet. 1. Abrasive damage. Moon dust is sharper than sandpaper. Its jagged grains can cut into fabrics, slice into seals, and grind down machinery. During Apollo, visors became scratched after only hours of use. Suits suffered wear in unexpected places. For a colony meant to last months or years, this wear could become catastrophic. 2. Mechanical clogging. Dust infiltrates every moving part. Hinges grind, bearings seize, air filters clog. A single grain in the wrong place can ruin equipment worth millions. Apollo astronauts reported that zippers and joints stiffened rapidly, and dust infiltrated tools, no matter how tightly they were stored. 3. Electrical interference. Charged dust can cling to electronics, potentially causing short circuits. Solar panels, so crucial for power, can lose efficiency as they grow coated with a fine, clinging film. Over time, this could cripple an entire colony's energy supply. 4. Health risks. Perhaps most worrying is what dust does to the human body. Inhaled deeply, the smallest grains may lodge in lungs permanently. Their jagged edges cut tissue, creating wounds that do not heal easily. Scientists worry about long-term risks, such as silicosis, a disease that affects miners on Earth who breathe in silica dust. Some experiments suggest lunar dust could be even more harmful. 5. Radiation complications. Dust is not just sharp, it is reactive. Bombarded by solar radiation, grains may carry trapped particles that interact with human tissue in unknown ways. Exposure could create new health risks that we are only beginning to understand. Unlike snow that melts or sand that can be washed, lunar dust is permanent. There is no rain to wash it away, no wind to scatter it, no natural cycle to bury it beneath fresh soil. Every step taken stirs it up, and once disturbed, it lingers. Imagine living in a house where every day more grit seeped in, scratching floors, coating lungs, eroding furniture, and there was no way to sweep it clean. That is, life on the moon. The Apollo missions, though short, provided warnings. Airlocks filled quickly with dust, leaving astronauts struggling to keep the cabin habitable. Gloves wore thin, with some seams showing fraying after only a few hours. Filters clogged, forcing crews to spend valuable time cleaning instead of exploring. Health irritation appeared almost immediately, with red eyes, sneezing, coughing. If such effects were seen after mere days, what will happen after months or years? Scientists and engineers are not ignoring the problem. Solutions are in development. Electrostatic dust shields, thin films that use electric fields to repel dust from surfaces like solar panels. Self-cleaning suits, outer layers designed to resist dust adhesion, perhaps through magnetic coatings. Lunar washing stations, airlocks where astronauts can be vacuumed clean before re-entry. Habitat design, positioning structures to minimize dust exposure, even burying them beneath regolith for shielding. And yet, none of these solutions is perfect. Dust is stubborn. It clings. It resists. Like sand at the beach, it finds its way into shoes no matter what barriers you create. Imagine being an astronaut in such a place. At first, the wonder of living on the moon fills every moment, but over weeks, the endless fight with dust becomes exhausting. Every breath a little harsh, every machine a little slower, every surface a little dirtier. Dust is not just physical, it is mental. It erodes patience, creates unease, wears away the sense of safety. It turns the dream of lunar life into a constant battle with something too small to see, but too powerful to ignore. In this way, lunar dust mirrors our struggles on Earth. We dream of greatness, of cities and towers, but are undone by small, unseen things: rust, mold, sand, time. The moon teaches us humility, that even on a world without life, dust holds dominion. There is irony here. Humanity can build rockets that cross space, machines that survive the vacuum, systems that carry us to another world. And yet, we are humbled by powder, by fragments no wider than a hair, by the quiet resistance of dust. Perhaps there is comfort in that, the reminder that the universe is not conquered by the large and loud, but shaped by the small and silent. That survival depends not on ignoring dust, but on respecting it. So dust is more than a nuisance. It is a hazard, a saboteur, a test. Any colony that ignores it will fail. Any future built on the moon must reckon with it first. But dust is not only an enemy, it may also be a friend. Hidden within the gray powder is possibility, the raw material of survival. Next, let's explore how moon dust might not just endanger us, but sustain us, as resource, as shelter, as the very foundation of life beyond Earth. Moon dust as resource. Could the very dust that threatens to choke our machines and lungs also save us? Engineers studying the moon face a paradox. Dust is the #1 obstacle to survival, yet it may also be the #1 solution. For hidden within those gray grains are the raw materials we need: oxygen to breathe, bricks to build, shielding to survive. The moon's enemy may also be its gift. Picture the first human settlement on the moon. At first, supplies arrive from Earth: oxygen tanks, metal beams, protective panels. But every kilogram costs millions of dollars to launch, and Earth cannot provide forever. Soon, the settlers must turn to the ground beneath their feet. They step outside, scoop up a handful of dust, and ask, "What can we make from this?" The answer is remarkable. Nearly everything. 1. Oxygen from dust. Lunar regolith is rich in oxides, compounds of oxygen bound with metals like silicon, iron, and aluminum. By heating dust to extreme temperatures or passing electric currents through it, oxygen can be released. This oxygen could fill habitats, fuel rockets, sustain life. In fact, scientists estimate that the top few meters of lunar soil could contain enough oxygen to support billions of people for decades. The challenge is unlocking it efficiently. Methods such as molten salt electrolysis or hydrogen reduction are under study. The principle is simple. Dust becomes breath. 2. Building materials. Dust is not only chemistry, it is construction. Its grains can be sintered or melted together to form bricks and tiles. Using solar concentrators, regolith can be fused into hard blocks for walls, landing pads, or protective shells. Some experiments have used 3D printing techniques, layering regolith simulant into shapes that harden into stone-like structures. Imagine printing an entire base directly from the dust outside your door. 3. Radiation shielding. Cosmic rays and solar storms pose lethal risks on the moon, but dust, piled thick, can protect. A habitat buried beneath meters of regolith would be shielded from harmful radiation, turning the moon's hazard into its armor. In this way, dust becomes not enemy, but shelter. 4. Metals and minerals. Lunar dust holds iron, titanium, aluminum, and silicon. These could be refined for tools, electronics, and solar panels. Titanium oxides, in particular, are abundant in some lunar regions. If harnessed, the moon could provide not only survival materials but high-value metals for use in space. 5. Water from solar wind. Though the moon is airless, its dust contains traces of hydrogen implanted by the solar wind. Combined with oxygen extracted from regolith, this hydrogen can form water to drink, water to grow food, water split into fuel for rockets. This concept, in situ resource utilization, ISRU, is central to future exploration. Instead of bringing everything from Earth, astronauts would live off the land. Dust becomes oxygen, walls, shielding, even glass for windows. NASA, ESA, and private companies have tested this vision with lunar regolith simulants. Robotic missions in coming years may attempt to extract oxygen directly on the moon. Artemis missions could build the first real demonstrations. The goal is independence, a settlement that survives not because Earth sends supplies, but because the moon itself provides. The paradox is striking. Dust cuts suits, clogs, filters, irritates lungs, yet it also hides the keys to survival. The very grains that scratch visors can be melted into domes. The same particles that choke airlocks can release oxygen when heated. It is as if the moon demands a test. If you can master my dust, you can stay. If you cannot, you must go home. Think of the possibilities. Roads carved from sintered regolith, domes built from 3D printed dust, glowing softly under starlight, solar farms stretching across plains, their panels made from lunar glass. Children of the future, breathing oxygen released from the very soil they walk on. The settlers would no longer live as guests, but as residents, not just surviving, but belonging. There is a kind of poetry in this transformation. Dust as adversary becomes dust as ally. Powder becomes brick. Silence becomes shelter. Gray powder becomes life itself. On Earth, we often discard dust as waste, sweep it aside, but the moon reminds us that even the smallest fragments can hold worlds of meaning. Dust is not the end of things, it is potential, waiting quietly, endlessly. Perhaps this is the true gift of exploration, to see not only the obstacles, but the possibilities, to take what hinders us and turn it into what sustains us, to learn that survival depends not on conquering nature, but on cooperating with it. In this way, lunar dust is more than matter. It is a lesson that fragility can become strength, that danger can hold promise, that even on a barren world, there is generosity hidden in gray. So the dust that scratched Apollo visors may one day form the walls of lunar homes. The powder that clung to boots may one day fill lungs with oxygen. The moon, in its harshness, offers not only challenge but gift. But dust is not only science, it is also symbol. For as long as we have spoken of existence, we have spoken of dust as memory, as mortality, as mystery. Next, let's step back from engineering and enter the realm of meaning, the symbolism of dust, and why something so small holds such weight in the human imagination. The symbolism of dust. Why does something so small feel so meaningful? Dust is ordinary, everywhere, invisible until sunlight catches it in the air. Yet in our stories, our rituals, our deepest thoughts about life and death, dust carries weight. We are reminded of it in churches and temples, in poetry and scripture. Dust to dust. On the moon, dust takes on even deeper resonance. It is not just a nuisance or a resource. It is a mirror showing us who we are, where we come from, and what we will return to. Picture an astronaut standing on the moon, gazing back at Earth. Behind him, the gray plain stretches endlessly, silent and still. At his boots, fine grains of dust cling to fabric. They are ancient, unchanged for billions of years. Ahead of him, suspended in black sky, floats earth-blue oceans, green forests, clouds swirling in white, and between the two, in that moment, lies a kind of poetry. Dust at his feet, vibrant life before his eyes, the smallest fragments of matter, and the grandest story of existence. The astronaut lifts a boot, and dust rises, floating briefly before settling back. A reminder, even here, in silence, motion never ends. Even here, fragments speak of eternity. Let's anchor symbolism in fact. Dust is not unique to the moon. It is everywhere, shaping both our world and our understanding of it. 1. Stardust and origins. Every atom in your body was once part of a star. The carbon in your cells, the calcium in your bones, the iron in your blood, all were forged in stellar furnaces billions of years ago, then scattered as cosmic dust across the galaxy. In time, that dust coalesced into planets, oceans, and life. When we say, we are stardust, it is not metaphor, it is literal. The moon's dust, Earth's soil, your own body, all are fragments of stars that died long ago. 2. Dust as mortality. Human cultures have long seen dust as a symbol of endings. Ashes to ashes, dust to dust. To become dust is to return to the earth, to dissolve into fragments after life has passed. Dust represents both decay and continuity, the reminder that nothing lasts forever, but everything continues in another form. 3. Dust as memory. On Earth, dust accumulates in forgotten corners. Each particle carries a story. Pollen from plants, flakes of skin, fragments of stone. It is the archive of a place. On the moon, dust holds memories far older impacts, radiation, and cosmic events. Dust is memory, whether of a single home or an entire solar system. 4. Dust as cosmic unity. When astronauts carried moon dust back, they were carrying part of us too. The same atoms that make Earth and life are present in that gray powder. Dust unites worlds, reminding us that division is illusion. Everything is fragments of the same ancient whole. Throughout history, humans have given dust meaning. In sacred texts, dust represents humility, the reminder that we come from simple origins. In literature, dust symbolizes both neglect and eternity, the forgotten and the timeless. In science, dust is possibility fragments that build stars, planets, and futures. On the moon, all these meanings converge. The astronaut brushing dust from his glove is brushing off history, mortality, stardust, all at once. What could be more profound? There is comfort in dust. It tells us that nothing truly disappears. Things may break, crumble, scatter, but the pieces remain. They drift, combine, form again. A star dies, and its ashes become a world. A person passes, and their atoms return to air, to soil, to water. Dust is the silence between words, the pause between breaths, the residue of time itself. On the moon, dust waits. It does not decay, does not change, does not vanish. It holds the stillness of eternity, and yet, when touched by human boots, it rises in soft fountains, as though reminding us, even fragments can dance. Perhaps this is why dust resonates so deeply. It shows us the balance of fragility and endurance. Small, breakable, scattered, yet unending, eternal, connected to everything else. And so, when we whisper dust to dust, we are not speaking of endings. We are speaking of cycles, of continuities, of the quiet truth that we are part of something vast and unbroken. So, lunar dust is more than powder. It is metaphor, memory, mortality, meaning. It links us to stars, to time, to each other. But even with all we know of danger, of resource, of symbol mysteries remain. For the moon still keeps secrets in its dust, questions unanswered, even after 50 years of study. In our final journey, let us wander into the unknown, the secrets of lunar dust we still cannot explain, the secrets we still don't know. What are the questions NASA still can't answer about moon dust? Half a century after Apollo, after decades of study, after thousands of papers written, lunar dust remains unsolved. We know it scratches, clings, irritates, and sustains. But deep mysteries remain mysteries that whisper of surprises awaiting the next explorers who step onto that gray plain. Picture a crater at lunar dawn. The sun edges upward, shadows retreat, and the surface glows silver gray. In the silence, the dust lies still. And yet, not everything is known. Beneath the apparent stillness, questions linger like hidden currents. Astronauts will one day return. They will breathe lunar air, filtered through machines, step across regolith in new suits, carry home samples untouched since the dawn of time. And as they do, the moon will pose its quiet riddles once more. 1. Long-term health effects. We know lunar dust irritates lungs and eyes, but what happens after months of exposure? Years? The Apollo crews were exposed for only a few days. No one has lived long enough on the moon to learn whether the dust could cause chronic illness, fibrosis, even cancer. Animal studies on Earth suggest dangers, but we do not yet know the full story for humans. 2. Strange chemistry. Moon dust is chemically reactive in ways we don't fully understand. When exposed to air and moisture, it releases unexpected odors, reacts with oxygen, even sparks in some experiments. Could prolonged contact with lunar dust alter habitats or equipment in unforeseen ways? Might hidden compounds emerge under conditions we haven't yet tested? 3. Electrostatic mysteries. We suspect dust levitates because of charging by sunlight and solar wind, but the exact mechanisms remain elusive. Apollo's instruments detected anomalies. The fountain model is plausible, yet unconfirmed. Will Artemis missions find the horizon glow again? Or will they reveal something stranger, a hidden atmospheric effect, an interaction we've never seen? 4. Cosmic archives. Each grain of dust holds records of ancient radiation, solar cycles, and even galactic events. But we've studied only a fraction. Could lunar dust reveal changes in the sun across billions of years? Could it carry signatures of cosmic rays from distant galaxies, fossilized in silence? Some scientists think the moon may be the best archive of cosmic history in the solar system, an untouched library waiting to be read. 5. Water and volatiles. Recent missions have hinted that lunar dust, especially near the poles, may hold more water than expected. How it formed, how it is stored, how it moves across the surface. These are mysteries still debated. Some grains appear to trap molecules of hydrogen and hydroxyl from the solar wind, releasing them under heat. Could this water resource be larger, deeper, more abundant than we dared hope? 6. Unknown hazards. The truth is, no one has lived with lunar dust long enough to know its full effects. Could there be hidden toxicities, unforeseen interactions with human biology? Could dust particles, when suspended in habitats, act differently than on Earth? Until we test it in real time, on the moon, the questions remain. NASA's Artemis program aims to return humans to the moon in this decade. Among its goals, to study dust more deeply than ever before. New instruments will measure its motion, chemistry, and behavior. Astronauts will spend weeks, not days, among it. Their health will be monitored, their habitats tested, their equipment stressed. The moon will reveal more of its story. And with each revelation, dust will shift from mystery to knowledge, though some questions may never be fully answered. Why does this matter? Because dust is not just the moon's story. It is the story of every airless world. Mercury, asteroids, Mars's moons, all are cloaked in regolith. If we dream of exploring them, we must understand how dust behaves. And beyond that, dust is the story of the universe. Cosmic dust gave birth to stars, to planets, to life. Lunar dust is one chapter in that grand saga. By studying it, we glimpse the forces that shaped everything we know. There is something humbling in these unknowns. We can land rockets on another world, build machines that survive the vacuum, send telescopes to the edge of the universe. Yet we do not fully understand dust. Perhaps that is fitting. Dust is small, overlooked, ordinary, and yet it holds secrets too vast for us to master easily. It reminds us that the universe is not conquered in leaps, but understood in fragments, that even the tiniest grain can contain mysteries large enough to humble us. So, as you rest tonight, imagine those grains lying silent on the moon, each one a question, each one a memory, each one a fragment of a story we are still learning to read. And when astronauts return, they will bend low, scoop dust into gloved hands, and bring the questions home once again. So we have walked with dust, as hazard, as gift, as symbol, as mystery. We have seen how it clings, how it glows, how it sustains, how it puzzles. But now, our journey comes to rest. It is time to gather the fragments together, to close the circle gently, and to let the dust settle into silence once more. Let us drift into our closing, a gentle summary of the path we've taken under the quiet light of the moon. And so, our journey through moon dust comes to its quiet end. We began with that first step, the print pressed into the gray surface in 1969, and we discovered the truth behind the romance. Dust that scratches, clings, and smells faintly of burnt gunpowder. From there, we drifted back in time to the violent birth of the moon, to the storms of impacts that ground rock into powder, finer than flour, yet sharper than glass. We listened to the astronauts themselves, their voices recalling eyes that watered, throats that burned, suits and visors dulled by abrasive grains. We watched as dust rose mysteriously into the lunar sky, glowing faintly at twilight, as though the moon itself were breathing softly in light. We considered the dangers it poses to future colonies, dust infiltrating machines, clogging airlocks, scratching lungs. Yet we also dreamed of its promise. Oxygen hidden in its chemistry, walls and domes 3D printed from its grains, shielding that could protect from cosmic rays. Dust as both enemy and ally, hazard and gift. And then we stepped into meaning. Dust as symbol of stardust and mortality, of memory and cycles, of fragility and endurance, each grain a fragment of time itself, linking us to stars long dead and futures not yet born. Finally, we lingered with the mysteries unsolved, the unknown health effects, the strange chemistry, the levitation that still puzzles scientists, the cosmic records sealed inside each grain. Questions waiting for Artemis, waiting for the next boots on the lunar surface, waiting for us to return. As you drift now toward sleep, remember, you do not need to hold all this in your mind. It is enough to let the words pass, like dust in a quiet shaft of light. Your body knows how to rest, your breath knows how to slow, your eyes know how to grow heavy. Somewhere above you, the moon still turns, its plains still covered in gray powder, its dust still whispering stories we do not fully understand. And somewhere, across the world, others are falling asleep to this same story, connected with you in this shared rhythm of listening and rest. Thank you for joining me tonight on The Science Pulse. I'd love to know where you're listening from, what corner of the earth holds you as you rest beneath the same moon. For now, let your mind soften, your body sink deeper into comfort. The moon is watching, as it has always watched. The dust is waiting, as it has always waited. Good night. Sleep well. and may your dreams be filled with starlight, silence, and the soft shimmer of dust.